Here's the bicycle class so far. We've got gears, current speed, current gear. We wrote shift up, shift down. We wrote brake and pedal, and brake has got something in it to limit us to keeping our speed 0 or greater. And we have unit tests for a whole bunch of things. By the way, if you haven't used this before, this little index here will take you to particular places in the code. So you can start to see that we've already got lots of little methods in here. This is the easiest way to find things. No more scrolling up and down trying to find the thing that you want. And one extra little thing, if you click on the A to Z button, it will put it in alphabetical order for you all the time, which usually makes it even easier to find. Okay, so that's the tool that you should be using to search for stuff. Okay, so we did some unit tests for braking, and we got to the point where we could gear up at least once. So now it's time to start gearing up a bunch of times. Okay, so we'll write a unit test and we'll try to gear up a bunch of times. Whatever that happens to be. We can steal this same thing here, and we can write a unit test that just does a bunch of shift up, and eventually, oops, do a bunch of them, and we're going to end up in what gear?
5? No, 6.
Good unit test or not so good unit test?
Not so good. It would be better if you tracked it going up all the way, each step.
Yeah, a couple of things here. The first one is that already people are going, well, is that 5 or is that 6? And if there was a pattern in there, it would just go 1, 2, 3, 4, 5, 6, whatever, and it would be pretty obvious. There's another more insidious reason here, is that, remember I said that you've got your crazy 12-year-old brother who could try to mess with you? Well, in the bike instance, the brother could decide, well, okay, you gear up once and I'll end up in first gear. You maybe go from first to second. That's fine. That's what the previous test did. From now on, every time past second gear, I'm going to stick you in gear 6. Okay? And if they did that, this test wouldn't show it, because this test has got a bunch of intervening steps before it gets to gear 6. Okay, so he could ignore you for 4 or 5 times and then suddenly go, oh, I feel like we should be in gear 6. Okay, so part of the thing about unit testing is this paranoia of going, I'm going to make sure that you go every time I ask you to do something, shift up, I double check to make sure you did the appropriate thing. And you can't risk doing 2 things in a row in general without checking, because it could be 2 wrongs make a right and it magically ends up at the same place. Okay? So the best thing to do here would be not only to shift up, but every time we shift up, just do a quick check and see whether or not we're in the right gear. So just let me get some of that code in there, a whole bunch of copy-paste stuff in there. And now it goes from 1 to 2 to 3, oops. To 3 to 4 to 5. And so at least the first time, we've now got some sort of obvious pattern. Sometime in the future, I don't mind if you crank it up to something else in some fast way, now that you've tested it to make sure it gets up to at least 6. That's not so bad. Run the thing, and if we're lucky, the unit test still works just fine. Okay, what should we test now for shift up.
And you shift down.
Pardon me? If it hits the maximum and stays there. Okay, well, let's see. That means we're going to go up to 21 gears on our bike.
We should make a new bike.
That would be a lot of copy and pasting. So the sort of the sneaky thing to do here is to say, well, okay, what I'm going to do is I'm just going to make a lot smaller bike. So let's make actually let's make a unit test first. So I'm going to steal most of this unit test. Oh, look, it's got a bike there already. That's a different one, but that's okay. Let's just take that one. There's stuff that makes a bicycle. Make a unit test that does that. Change the name of it to shiftUp. Stays at maximum. And now I'm going to make a little bit of a smaller bike, 3-speed. I'm going to call this 3-speed just so that there's no issue there. And then I'm going to do 3-speed. Control space is probably your friend here. Oops. 3-speed dot shift up. And just because I get confused, I'm going to steal the thing that says that I think it should be starting out in gear something or other, whichever test that was. Here we go. Steal something for gears. Oops. Down at the bottom. Make sure. By the way, notice what happened there when I cut and paste? See something? Well, no, notice what it did with this one. Where's this one coming from?
It's off the top.
This one's coming from the one up top because that one's still defined. So there's one of the issues with this idea of what we would call global variables in computers. Is as soon as you move that one up to the top and it's visible to everybody, sometimes it gets in the way and does bad things. In this case, it's a copy-paste error. I'm not expecting that one to be used, but all of a sudden I've got another variable in play that I never expected. Okay, so one of Pfeiffer's rules says that copy and paste is almost never your friend. Okay, because it does little silly things like that that are going to be hard to find eventually. So be very careful when you're copying and pasting. So there we go. It's in gear number 1. I can do a bunch of these. It should now be in gear number 2. It should go to gear number 3. And then one last time, if we shift up again, it should stay in gear number 3.
Might want to get rid of the initial 3-speed shift up.
It should be that one. Okay, done.
Miss the at test.
And missed the at test. Thank you. Got it. Run the test. Oh, it fails the test.
We haven't put in that code yet.
Because we haven't put in that code yet, which is perfectly fine. You want it to fail as you're adding restrictions. So now we'll go back into the bicycle and we'll go, oh, what should we do for shift up? It just keeps going and going.
Put in an if current gear. Well, first you have to get current gear.
Don't have to get current gear because you own the gears.
Oh, okay.
So if we're already at not 3, but
Maximum, your maximum.
Yeah.
there's that weird variable that would be better called maximum gears. If you're already at the maximum, what would you do?
Return, do nothing.
Just do nothing. Okay? And so notice that think I've used the other people's code, but that's okay. So notice that gears variable there isn't the best. So if I rename it to maximum gears, then suddenly that thing makes a lot more sense. Okay? And there's the joy of refactor again. Anytime you go, well, hold it there, that's not gears, that's actually maximum gears. Somebody says it or you say it in your head, you make the change, and now the code becomes a little easier to read and probably a little more robust because of that. So now we can run the test, and now the test passes. Okay. One other quick question here. What about writing a loop? The alternative to doing this test I'll just write another one, would be to make a bicycle there's a bike less than and an app test. ShiftUp. Steal that line. How about that?
50,000 a bit excessive?
This is known as abuse the bicycle. You always get that kid that runs the thing up to top gear and then proceeds to just crank at it for no apparent reason and go, we're just going to see if this thing works, right? So it could be 3, it could be 4. 50,000 is nice because there's not much doubt that it's going to exceed the number of gears in the bike. Which one of those tests do you prefer?
The second one.
Last one.
No, it's not really any different.
Which one of those tests is easier to explain to mom?
First one.
First one.
Also, you could run into that problem that you said before, where every gear could be 3.
Yeah, every gear could be 3, so there should actually be an assert statement in here. So this thing should actually be current, we'll get the gear, and current gear should be I.
Minus 1.
Plus 1.
One or 2. Started out in gear 1, so the first time you gear up, oh, where have we done the shift up? We do the shift up afterwards, so okay, we check, so I guess that could be 1.
Should I start at 1 and not 0?
I could start at 1, it could start at 2.
Because like the gears are supposed to start at 1, aren't they?
See what just happened? All of a sudden, we add a loop. First step to, oh yeah, that's still understandable. Oh yeah, well, okay, now we should make it do what the other one did and check each value, and all of a sudden the check each value is, well, okay, now we have to think about this because I is going to start at 0, and that would make this one plus 1, or we could start I at 1, and if we started I at 1, then we still have to make sure we do the shift up afterwards. We can't do it before. We could check before to make sure it's in gear 1 and then shift up and then, right? You're going to explain that to mom? Are you going to explain this test to mom? You know, even if we started at 1 to try to make it more transparent? Right? So that's my point about loops make you play Mr. Computer as you're trying to read the code, and you get all of these little end conditions of am I off by 1 or am I not off by 1? Did I start in the right place? Did I end in the right place? That's what counted loops do to you. Okay? And life just got more complicated. And in this one,
Not to mention that would
it's
fail.
there's just no doubt about it. If this one fails,
Because it will fail.
then all of a sudden you're stuck with, oh, well, hold it here. My code for the bicycle here was only 3 lines of code, but now this test is this convoluted piece of, gee, I'm going to spend all my time trying to see if I can get this loop thing right. Okay? So this thing is a bad thing. It's evil for testing. It just makes you use way too much brain power for something that should be fairly simple. So we're going to stick with that.
It would have given you an error anyways. As soon as you got over 3, it would give the wrong value.
Whatever. It's broken. It's just a bad thing. So why discuss it, right? Why not do the simple thing? Okay, so there's a simple test. The one for, shift down is no different. If current gear is ever at gear number 1, then we can't go anywhere. Okay, so it's just basically the converse of the thing. So that's, I don't want to bore you with bicycle now because you've seen the sort of the basics of it. The one thing people have been asking about that apparently I didn't explain to everybody for some reason was the silly toString. So let's talk about the toString for a second. So here's the driver, and let's go back to 1970 when people actually printed out stuff. And suppose that you want to print out the information about the stuff that's in the bicycle. What's your print statement going to look like? My bike dot, what do we got here? Get current gear plus, I guess we need my bike dot get current speed. Anything else in there right now? Or is that it? Let's just go look in bicycle. We've got current gear, current speed, maximum gears. Those, did we not do one for get maximum gears? Oh, sure, we'll put it in. There's maximum gears. So now we've got all those things, but I guess we should add some separation to them. So we'll put in a plus sign there, and we'll put in another one there. Should sort of do the trick. And then we'll run this thing and print out the values. And there's the 1, 1, and 21. So now it's like, oh, well, I guess I should really say what those are. So I'll do current gear is this, and maximum speed is that, or so is that current speed?
Yeah, correct.
Current speed. Current speed, and this one is maximum gears. Just so that the numbers make some amount of sense. We put colons on them,
In this space.
and if I got that sort of right when we print it out, It'll print out current gear, current speed, maximum gears. It's sort of a little bit hard to read, and since I'm a programmer and I'm really just doing this to dump out all the values, I'm just going to run these together, because then when I look at the printout, it's really sort of easy to parse. There's a name and a value, a name and a value, and they just come in nice pairs. Okay, so it's fairly simple to read. Got it. By the way, if you haven't used it, there's source format. And after you've made a whole bunch of wacky changes and got your formatting wrong, you can do source format and it'll do something nice for you in the approved Java style. Okay? We're not going to argue anymore about where braces go or don't go or any of that sort of silliness. You just do whatever the formatter does, and that's the style. Okay? Nice and easy. Done. Okay. So there's our output. The only reason that I really put that in was sort of for debugging in the old days. I just want to dump out all of the data values that are in the object. What happens if I add another data value in here?
You have to append the other one.
Then I have to go back into the driver and remember, oh, okay, I changed, the bike has now got more information. I have to print out more information. Okay? So in other words, the driver now has to know how much information the bike has, which is sort of annoying. They're tied together somehow. The way to get around that problem is to say, why don't I just go into the bicycle class and provide a nice little utility that will give me all of that information all at once. And so I'm just going to go into the driver here, and I'm going to steal exactly that stuff there, and I'm just going to say, it would be really nice if the bicycle could just do that for me. And so I'm going to take exactly that same code, and I'm going to say public string get all information. And like so, and then that just be, oops. Oh well, I'll try one more time. And that just becomes return all of that crud, and this is just, since it's inside the class, I don't have to call a getter. This is just current gear, current speed, and maximum gears. Okay, so notice as soon as I slip into this inside the class, I'm just using the variables directly. It's the same piece of code. It just takes all of that stuff and sends it out where it can be seen. Okay? And so now this thing in the driver, there's where that other garbage went. In the driver, all we have to do is say my bike dot get all information, and it will print it all out. Same deal. The advantage of that is that now if the bicycle class gets changed and somebody comes along and adds in more information, it's the responsibility of whoever's writing the bicycle class to go add this information into the end of this routine. Okay? And now the driver program doesn't care. The driver program just says, give me all you've got. Okay? So there's the idea that a Java class, one of the other things that they do is they provide this utility, this extra functionality that makes life easier for whoever is going to use them. So in this case, easier for people who are printing. Okay? So there's the first thing that it does. Now, the other trick to the game is, what format should this be in? I've said that this thing is rarely going to be used by your mom. It's really intended for programmers, and it's really intended as a data dump on a print statement. And so I'm not going to make it fancy and say, oh, by the way, let me be really chatty and tell you that this is the best bike in the world and it has the value of this for gears and da-da-da-da-da. I just want the simplest format of information I can get, which is just the name of the variable and a value. And as a trick, it's actually better off to do them in the same order when you print them out as they were declared up top, and make sure you get all of the variables that were up top, because then it's just easy to see that you've done them all. So there's 3 lines of code here, 1 for each variable. There's 3 lines up top. I know I got all the variables. It could be anything you want, but if you stick to a nice consistent format, it's just easier. What I did was I did virtually the same thing in the original student driver, except I made a variable to do this. Here I'm just sending back the lines all composed. Either way sort of works. Okay? But that's all there is to it, just the name of the variable followed by its value. Now, it turns out that that feature is fairly useful, and so they made a name for it, and they said what you should do is you should write mybike.toString to do that. And so this thing, the actual name is toString. And toString says, give me all your information. That's just the name I use. Convert this data to a string. I think it's a silly name. I would have preferred get all information, but what the heck. Okay? So now when you run the driver, it still does what it's supposed to. Except, Java people being lazy, they get tired of typing toString all of the time, and really what you'd like to do is to say, gee, if I mention the name of the variable, why don't you just do whatever the toString says to do? Which makes it just like any other variable. Print out the data values for this variable. Seems like a reasonable thing to do. So we'll try that. Turns out they made it smart enough that anytime you want to get a string out of an object, that's what you can do. And so the print line is smart enough to go, oh, well, if I see a variable, I'm just going to call variable.toString for you, and you don't have to type it. And you can still see that that's our thing being called. Well, what if you leave it out? Well, one way to leave it out is to accidentally misspell it. So I like to sting, because I'm a lousy typist. Okay, so now that's not the standard one. Okay, that's something totally different that looks sort of the same. And so now when you run it, you get that. That happens to be the memory address for that particular object, more or less. And so that's the default is to say, if you want me to print out a variable, the only thing I know about where it is, I don't know anything about how many data values are associated with it, because you could have a ton of them in there, so I'll just print out the memory address, which is sort of annoying. So anytime you see gobbledygook like that being printed out, then you now know, oh, okay, I forgot to do the toString. Well, it turns out that people are such bad spellers that they add one of these little @ symbols over top here, @override. And @override says, I know that there's an existing one of these someplace, and what I'm trying to do is replace the one that's already there, the default one, with a better version of my own. Okay? And now the compiler is going, well, wait a minute, you said you were going to replace something, but there's nothing there by that name, so that's an error. So this is just a hint to the compiler saying, I'm planning on replacing something I know is already there, and so now when you put that thing back in there, the compiler's happy again, and you've now got a valid toString. Does it get used anywhere else? About the only place you'll see it, like I say, is if you dare to print out a variable, which we're never going to do in this class because we have the debugger. But the other place it is used is if you run the debugger on the driver and you happen to go and select the MyBike variable in the debugger. On the line below it shows the toString. And as a matter of fact, I wonder if we're lucky, and if we mouse over it, there's also the toString down below. If you got the debugger, it's so useless because it's already showing you what you needed to know. And so for our purposes, the two reasons I'm showing it to you is just an example of here's a little utility that you can provide that does extra stuff, and we're going to end up overriding other things eventually. And so it's just nice that you can see that that facility is available. Okay. So there, now I only have to say that once instead of another 5,000 times. Okay, last call for questions about Bicycle before I leave it in that state. Okay, it's not quite finished, so feel free if you want to go add some more unit tests and fix up that other stuff. Let's try something else, since we've got a little bit of time. What have we got left? We did most of those. toStrings. We could add a custom name decal. Yeah, that's probably a good thing to do, just to remind you one last thing about constructors. So I'll do that for you really quickly. So here's one version of ordering a bike from the factory that says this bike, I want this many gears. That's all you can do with it. But if we want to make a little bit of money off people, maybe when they order their bike, we want to silk screen their name or something onto the front, or their company, or whatever it happens to be, if we're making these bikes for some company, right, making a whole whack of them. So let's add in another constructor that says public bicycle still got to order it with the number of gears, but now we're going to have a string with some sort of decal on the front of it, or silk screen thing on it. And so now this thing looks exactly like the other one. So we'll use that same information for initialization. This should be in gears. But we'll add something up here to remember. So we'll call this one in decal, and nobody will know what a decal is, so we'll have to think of a better name. So in this case, the decal is nothing, and I'm going to make it officially nothing, not even a space. And in the other case, the decal is whatever they say it is. And the only other thing that we can do with this is somebody can ask the question, get decal. Okay? There's another typical example. Somebody comes along later and says, I want to retrofit this class by adding more information. So now we've added more information. What should we do when we add another variable up top? Got to add it to the toString, so we'll go down to the bottom here and we'll add in another plus. The decal happens to be that. And yeah, that'll work. Got it. Okay, so now it becomes my responsibility to fix the toString because it's part of that class, and off we go. To use the thing, now you can go into your driver, and a different example would be to make, just steal this one since I am an awful typist. There's another one called your bike, and now you can make a bicycle and you can put Fred's name on it. Okay? So there's another example of now you have two options for when you order a bicycle. Either one works. Okay? Okay, and that's all constructors are, is when it's first made, what do I want it to look like? Here I've filled in 2 of the 4 possible things, and the other ones we set in the class ourselves. Okay, whew. Done with constructors. Okay, now let's talk about something new. So I'm going to close up pretty much everything I have. And we need a different example. So, if you're in the airline business, airlines in particular have a pretty heavy-duty set of requirements for how they do maintenance on aircraft. And any of the governing bodies make mechanics keep track of all sorts of interesting things about literally every piece that's on the aircraft. So every piece on the aircraft has got a serial number, and every piece we know how many hours it's been in use and what it's been used for, and all sorts of things. And when it reaches its day for refurbishment, it's got to be taken out and refurbished and put back in and documented and all that sort of stuff. Okay, so the simplest thing that we can have, just to do an example, is something like just an aircraft engine, and the engine will have a serial number, and the engine will have a maximum amount of time from the manufacturer that it's supposed to be in service and running before it has to be taken out and refurbished and redone. Okay, so there's some sort of requirement that says that that's what it has to be. Okay, so what we're going to do is we're going to write a class that represents a fairly simple bunch of data for a single motor. And then, just to get a little bit fancy, we're now going to pretend that we're a shop that's got a whole bunch of motors or a whole bunch of planes. And so now we're going to start to get the idea of, oh, okay, we need lists of motors. We need to keep track of lists. We need to do things like search the list to find out what motors of all the ones I've got on planes are the ones that are in need of maintenance. How much are they past their due dates? Which is the worst motor that needs to be done first? All of those sorts of questions. Okay. So let's go start out with a class that represents a motor, and we should be able to get this one more or less built reasonably quickly. So I'm going to make a new Java project. I'm going to call it motors for want of anything else, and remind you that basically all you have to do is click finish these days, and we've now got our motors thing. We're going to make a brand new class, and this time I'm not starting out with the main program. I'm starting out with a single motor because I think that's the interesting thing. So no main, we'll just get that going. Okay, what information do you want to store about a motor? Need a serial number, so that's now private string serial number.
Hours of service.
Hours of service. Private int hours of service. And
Installation date?
we won't get stuck with dates yet. What goes with hours of service?
Maximum hours.
Maximum hours before you end up having to do something with it in the shop. So we're going to have private int maximum hours before service. Okay? If we were to make one of these things, what information would we supply?
All three.
We'd supply the serial number, we'd supply the int, it should be in serial number just to be consistent, and this one I can steal that thing. What about hours of service? Should we allow people to set that?
Could be a used part.
Could be a used part, but we don't like to deal in used airplane parts, so probably it would be nice if we had full control and people just couldn't come in and arbitrarily change things. So for our purposes, we're gonna say we only buy motors and then they're ours, and we deal with them so they always come in fresh.
Should you put in front of maximum hours?
Okay, so the initialization is serial number equals in serial number, so control space is your friend, control space, try to get them in the same order. Hours of service equals 0, and maximum hours before service equals in max before service. So long names are fine, control space will be your friend. Okay? What about getting information out? It's got to be a get serial number. You remember the first time we started doing this and people thought it was incredibly difficult? And now it's sort of like, yeah, okay. So there's serial number. So we'll need getters for each one of those. And by the way, I've seen some people in the lab that aren't following the official rules for Java. Classes are the only things that get capital letters, so that you can tell that they're a thing. Everything else starts with a small letter and has a capital thereafter. So that's the easy rule. There's return hours of service, and one more. Get that one. Got it. So there's the start of the motor class with all of the getters. Now we can start worrying about the sets. What's the thing that's going to change for this motor?
Hours of service.
Hours of service. So there should be public void set hours of service.
Add hours of service.
Add hours wouldn't be bad. So the thing that comes in is what?
Flight hours.
How's that for a name? So that's hours of service minus equals flight hours. Why should it be plus equals?
Because you're adding it to it.
Nothing there that tells me it should be plus equals.
It says add hours of service.
Now I'll believe you. Sure, add says it, but there's nothing like reinforcing it, right? So now I see it twice. It says add, it says more. No, really, that should be a plus sign. Okay. Got time for one more quick one. What's a question that people are going to ask?
How long's left?
You're going to ask what?
How many hours of service are left?
How many hours are left? And what should it return?
The difference of
Maximize.
maximum hours before service and hours of service.
Let's use control space, I guess.
It's a long one.
Maximum hours before service minus hours of service. It's got to return an integer instead of nothing. Okay. Here's a debugging skill. This would be perfectly normal in most people's code, but the problem with it is, if you hit this line with a debugger, you're going to have to do the calculation yourself. Okay? And being the lazy person that I am, I'd prefer that the debugger showed me. So I'm going to put that up there, and then I'm going to return hours left. Okay? And that's strictly a debugging thing. When I put a breakpoint here, I get to see exactly what the result of the calculation is without doing any work. Okay? If you show this piece of code to somebody who's practically anybody, but certainly anybody who's been programming for the last 15 or 20 years, and anybody who's seen assembly language, they would go, oh my God, you're going to use an extra register to store that value. Okay? Or something along those lines. You really don't need that there. A couple of things. The first thing is that human beings are the expensive thing, so I'm not really interested in saving a few cycles on an instruction or a register. The second thing is that compilers are a lot smarter than they used to be, and when you compile this into code, it may very well remove that variable in the running code anyway, because it knows that it was just a temporary variable. Okay? So we're not going to get all hot and bothered about that sort of stuff. We're going to put all of our variables into nice intermediate calculations, and it'll make your debugging life just so much easier.
Make sure it works first before you
Okay.
make it pretty.
So what we'll do with this is we'll add another couple of methods. We'll write a little unit test thing just to make sure it works. And this thing stops being the interesting thing, and what's going to start to be the interesting thing is making lists of things and going and searching this thing. By the way, don't forget to run source format just to make it do all of the pretty stuff, and off you go.